Alright, so you can see that I've written the exact same problem 3 different times because I want to do it 3 different methods. Because I know sometimes doing it one way doesn't make sense, but hopefully one of these 3 will click with you and you can see and understand why we're doing what we're doing when we find radicals or simplify radicals. So when I take a look at these, for this first one I'm going to talk mostly about factor trees because that's what we focused with last year in algebra. So whenever I see a number that ends in 5, I know I could just divide by 5 to find the first part of the factor tree. There's a lot of different things you could do, but that's the first thing I saw. And usually any pair that you find should be valid as long as these two together would multiply to 525. Okay, so that's done, can't be broken up anymore. It looks like it ends in a 5 again, so let's divide here. So 5 and 21. Now this 21 can break up into 2 things. We'll divide by 3, and 7 is a pair I know, and these can't be broken down again. Okay, so when I take a look at this, I see that I have this right here, which is a pair. Okay, and it's a special pair because 5 by 5 is a square. Okay, and this is a square root, so I know this works. Right here, these two that are left, I've got 7 by 3. That is not a square, so it can't come out of the square root. It's not even. It wouldn't give us a decimal. So the thing here that is even, I can use this side that represents 5. Okay. And then this right here, this rectangle, it can't make it out. It's a decimal. It's not a perfect square, so I can't pull it out. So I'm going to put right here 3 times 7. So the final answer is 5 radical 21. I can check. Okay, square root of 525 gives us 22.91, and then I'm going to take 5 square root of 21, and see how I get the exact same decimal? That tells me that I've done it correctly. Okay, alright, so there's the first one. Okay, let's try again with a different method. Now sometimes it can be good to think about this a little different way, so I'm still going to actually use the same tree. 1, 3, and 7. But this time I want to talk a little bit more about thinking about this in exponents. So if I write it again, I have 5 squared times 3 times 7. I'm going to take a square root of the whole thing. Okay, so just ignore this from the last problem. Alright, now when you multiply, we can think about each problem individually. So let me move down here. I'm going to find the square root of the first part times the square root of 3 times the square root of 7, okay, because it's still all broken up, but still a square root of each of the parts. This number here together is just positive, pulled apart, and this is still this exact same number if I multiplied it together, because 5 times 5 times 3 times 7 would give us 525. I've just put it into parts. Now what's cool about this is this part right here is special, right? This is 25. Okay, 5 squared is 25. So the square root of 25 is even, I can get 5. I look at this next part, square root of 3, yeah, I can only get a decimal. Square root of 7, yeah, I can only get a decimal. We're only simplifying to get things that aren't decimals to be written in a better way. Okay, so suddenly this right here, square root of 25, ends up being on the outside. And this right here on the inside, those are decimals, so we can't deal with them. So we're going to write 5. We'll combine these back together, 21. Alright, now that way doesn't make sense, let's try one other way. Sometimes what's easiest in your mind, and probably you noticed this was 25, is to do something called pull out the perfect squares already. And so instead of just randomly doing factor trees, think to yourself, are there any perfect squares I know? And this one, I know if I pulled 25 out, so 525 divided by 25, that's going to give us 25 here and 21 on the other side. Now we can check, are there any perfect squares in 21? Yeah, this was 3 and 7, so that's a no-go. This right here is the perfect square. Okay, so then square root of 25 will do the same thing as we just did the last one, square root of 21. This right here just gives us a decimal, so we can't deal with it. We can't simplify it any further. This right here, that's good to go. This gives us 5, and there's our answer. Okay, so again, strategy, use the factor tree, circle the pairs. Remember, pairs end up with squares, they're on the outside, regular ones, rectangles, are still on the inside. Or think about it with the exponents and breaking it apart in each square root section. Or 3, think of it like pulling out a perfect square instead of a part of a square. And when you pull out that square itself, that helps us solve. If that's not enough or still lots of questions, post a question or send a text or ask me in class or stay after school or etc.